Okay, so searching and sorting CSES complete problem set solve speedrun. Let's see how much we can do. So, okay, first question, distinct numbers. You are given a list of n integers. Calculate the number of distinct values in the list. Okay, it's just okay. Oh, my fault. Oh god. So there are n applicants and m free apartments. The task is to distribute the apartment so that as many applicants as possible will get an apartment. Each applicant has a desired apartment size and they will accept any apartment whose size is close enough to the desired size. The first input has nmk, the number of applicants, the number of apartments, and the maximum allowed difference. The next line contains n integers, the desired apartment size of each applicant. If the desired size of an applicant is x, he or she will accept any apartment whose size is between x minus k and x plus k. The last line contains the sizes of the apartments. So n applicants, m apartments. Uh, Distribute the apartment so that as many applicants as possible will get an apartment. Size of each apartment. Print one integer. The number of applicants who will get an apartment. Is this? This does not seem like. This seems more DP. Wait. Whoever has the least requirement can be given the smallest size apartment that there is, right? So it's okay, then that just makes it iteration. Okay, okay, wait. So uh, okay, okay. So we have two sorted lists. Let's say apartments and applicants, applicants and houses. So that the first letter is different. I need to assign each applicant and house such that okay, so the smallest guy is the only person who can get the smallest house if possible. That's right. So I can keep two pointers, one that points to the current applicant and another that points to the current house. And then for each applicant we will increment the house until we find something that he would accept. Then if it becomes too big for him to accept, then we will start skipping over applicants apartments instead. Okay, so it's so what I would need is I would need an int nmk that I input, then I get vector integers houses size m, applicants size n, and for auto and Jane applicants we'll input the j. Similarly, for each of the houses we'll again input j. Then we have a house equals to 0 and applicant equals to 0, while house less than n and applicant less than m. Wait, okay, no, ulta. While house less than m, applicant less than n. Okay, so if applicant of if applicants of applicant minus k is bigger than the current house that we are at, we simply do applicant. No, wait, so the applicant requires some house, but the current house that we are pointing to is way too small, so we simply go to a bigger house, house plus plus. So we would need a house less than n here as well. And this is not a if, this is a while house less than n and applicants of applicant minus k greater than houses of house, we increment the value of house. Yeah, that makes sense. Then while applicant less than m and applicants of applicant plus k is less than houses of house, we can say applicant plus plus. Okay, so if house equal to n, we break, and here if applicant equal to m also, we break, and in the last case we simply increment the count. That means that we have fallen into a house that follows. No, right, this does not actually mean that we have reached a house. Would binary search work better? No, I feel two pointers should work better. Uh, okay, so we have two sorted lists. Okay, a list of apartments and a list of the applicants that want these apartments. Okay, so the desired value of each applicant minus k or plus k, that is the value of an apartment that they are willing to accept. So for a given applicant, we just need to increment house until we find somebody who will buy it. Yup. Similarly for the second guy as well, we just need to increment it until we find someone who will buy it. So let's say for the second guy we increment it and we reach some value and we say okay, so I'm going to buy it here. We can say CT plus plus. Okay, but what if as we increment, what if we reach some place where, yeah, we reach some place where the second condition becomes true, so then it enters into this loop instead, and then again goes applicant plus plus, and then we again fall into the first condition being true. In that case we can't go CT plus plus again. Okay, so the CT plus plus needs to be done here, I think. If wait, will this be the case though, that the current applicant is looking at something? The current applicant is being offered a house that is bigger than what he wants. In that case, we'll move to a applicant with higher ambitions, right? Yeah, so the applicant plus plus needs to be there. We just add here that if applicants of applicant plus k is greater than equal to houses of house, we can say CT plus plus. Then this second CT plus plus can be gotten rid of. I think this should work. Oh wait, sort. We forgot to sort. Sort houses dot begin, comma houses dot end. Sort applicants dot begin, comma applicants dot end. Then we can play this. Okay, it timed out. What are we not doing? Oh, okay. So this means that we have seen that applicant. So we can skip over this applicant. Oh, two. Okay. Why do I feel like it's going to give wrong answer? Hmm. Okay, I don't want to look at the test cases yet. So we just need to think a little more. The number of applicants that get an apartment is as simple as I choose the first applicant, okay? I find the smallest house that he would be willing to take. Then we go to the second applicant, and then from the current house we increment until we find the smallest house that he would be willing to take. Now the edge case is that if we find that, yeah, I think it should be done that way instead. So we can just go for int I equals to 0, I less than, how many applicants are there? N, right? I plus plus. So for each applicant basically, okay, we have a house value. So this house is the current house, is the last house that we have already sold. So if this was the least house that the previous guy bought, then definitely that could not have been bought by the current guy. So we can just start from the current one. So now we just increment it in but we need to also see the edge cases, that is if either applicant, sorry, if applicants of I is, no, plus k is less than the current house that we are at, house of CT, no, not CT, house of house, and also the case that house greater than equal to n. In both these case, we need to call a continue. Now if that is not the case, then we will increment house while houses of house minus k is greater than the applicants of I. Wait. For an applicant, so an applicant needs this much space. Now if the house is smaller than that, we can call house plus plus. Then the applicant will find a house that suits him. No, what if it skips instead to a house that does not suit him? Hmm, that's. Can I just copy this? Paste. Does it work if it is in the second? Huh. Okay. So you could do that. And then we could go house plus plus CT plus plus. So this is the case that house was found to be less than n, and we did not call applicants of I plus k, so we can instead call house plus plus and CT plus plus. Okay, so let's submit that. CP workspace. Oh my god, that's annoying. Okay, there's a while loop error somewhere. House greater than equal to n, we skip over it. uh, is there, okay, house can be greater than n here. uh, okay, no, it's house greater than equal to m, and we can't uh, yeah. Array bhai, CP workspace, submit. Think that should, yes, okay, Ferris wheel. Okay, so there are n children who want to go to a Ferris wheel, and your task is to find a gondola for each child. Each gondola may have one or two children in it, and in addition the total weight in a gondola may not exceed x. You know the weight of every child. What is the minimum number of gondolas needed for the children? Okay, so each gondola can only have either one or two children in it, and in addition the total weight must not exceed x. I know the weight of every child, but what is the minimum number of gondolas? Okay. Mm, okay. So how can we fit 4 and 10? So 10 is x, right? Okay, so if I'm allowed 10 in one gondola, we require a total of 3 gondolas, right? Makes sense. Uh, would we want to pair the would we always want to pair the heaviest child with the lightest child? Is that true? 9 and 2 cannot be paired actually. So 9 would have to go alone. We would like to fill it up as close to x as possible, maybe. That could be one thing. Hmm. Either that or pi less than equal to x. So either that or, let's say it takes me k gondolas. Can I, how do I know what is the right way to fill up these gondolas? Um, I can, so, okay, so, okay, if I can just check programmatically that I can't fill up two, then we can binary search on the answer. So if I land on the number 2 and I ask you, okay, is it possible to fill these children up in two gondolas? Um, to fill them up in two gondolas won't, no, it may be possible. Uh, isn't this just, I feel like a very greedy solution should work. Like what if I just, it's just sum divided by the, like the ceiling of the sum divided by x. Feel like that solution should work, but will it always? Okay, so I have a gondola and I can fill up. Will it work always? 10. Okay, so is there a case where the ceiling, okay, so the minimum value is definitely the ceiling, right? I will need at least the ceiling, right? So okay, so I will need at least the ceiling. Can I find an edge case where I would need more than the ceiling value? um so for an edge case to need more than the ceiling value, we need to think about the way that we are filling these gondolas up with weight x, right? So if I choose two at a time, if I choose two at a time, it would be the two out. Okay, no, the ceiling value is definitely not it because we can only choose two at a time. So if we had three numbers like 2 2 2, then this guy here would say that it only takes one gondola. If I had like 3 10 2 2 2, this would say it only takes one gondola, but it would take me two gondolas because I need to fill them up. So then is it the maximum of the ceiling of the sum, comma the ceiling of n itself? That is the case where everything fits perfectly in. No, but too greedy. Wait. Uh, 9 and 2. Yeah, so the heaviest child must be paired with the lightest child, right? Because if I pair it with something heavier, then I know for a fact that, okay, wait, if the heaviest child is, let's say, n, and then the lightest child is 1, and instead of pairing n with 1, I pair n with something heavier than 1 but lighter than n called x, okay? And then I have some partner of x called px. Then if n plus px, if n and x fit together and px plus 1 fit together, then for sure can I say that n plus 1 will fit together and px plus x will also fit together. Okay, wait, that could be a edge case, right? Because you can go 3 4 7 9. No, wait. I need the first and last to fit together, and the middle two to not fit together. No, but the yeah, but the weight reduces, so I it will all can intuit that it will always be the heaviest paired with the lightest. But I don't wanna code randomly. I want to be able to prove it. How do I prove that the heaviest must be paired with the lightest? Um, how do I prove that the heaviest child would it ever be instead if p plus x fits then p plus 1 will fit, we know that. But if p plus x fits, will x plus x1 fit? Oh yeah, x plus x1 will fit. So it is always just better to choose the edges because okay, okay, yeah, okay. Okay, so my proof is that if n is heaviest, 1 is lightest, x is somewhere x and x1 and x2 are somewhere in middle. If we pair, let's say n and x and n and x1 and x2 and 1, hmm, we know that if n and x1 does not fit, n and 1 might still fit. If 1 and x2 does not fit, 1 and oh no, if 1 and x2 does not fit, then we don't know that 1 and n might still fit. But if n and x1 do fit and x2 and 1 also fit, then n and 1 will fit and x1 and x2 will also fit. But what if x2 and wait if x shit if x2 and 1 fit and n and x1 don't fit, then n and 1 will fit definitely. So we still keep the 1 fitting and x1 and x2 might or might not fit. So we maintain yeah, so we maintain or do better always. We either maintain by choosing heaviest and then lightest, we either maintain or we do better. Yeah. I feel there should be better proof, but if A of L plus A of R is less than or equal to X, L can be incremented, R can be decremented, and CT can be incremented. Else R gets decremented and CT gets incremented and then C out CT. What? Oh, that's not right. Why is that not right? A of L plus A of R n x we take 7 to oh sort. What is wrong now is that we come to 2 and 3. A of L is 7, no, A of L is 2, A of R is 9, it does not fit. So we take one gondola and we put 9 on that. Okay. Okay, so I think if L equal to R, CT plus plus needs to be done. Yeah. Because in the last case, if L and R end up at the same point, we need to. Okay, nice. I will look at proof for it later. There are n concert tickets available, each with a certain price. Then m customers arrive one after another. Each customer announces the maximum price they are willing to pay for a ticket, and after this they will get a ticket with the nearest possible price such that it does not exceed the maximum price. Oh, this is just binary search right on a set. The maximum price they are willing to pay. So you give something less than or equal to the maximum price and then you remove that from the set. Is that it? 533785. We give him, okay. Last line contains m integers, maximum price for each customer in the order they arrive. Okay. Okay, this is easy. Control C, Control V. Wait. Okay, the price of each ticket. The price of each ticket may or may not be distinct. We don't know. Winter tickets. We are doing upper bound because we need less than equal to. So to get less than equal to, we first find greater than by using upper bound, and then we do IT minus minus. But before we do IT minus minus, we need to check what if IT is actually equal to tickets begin, because in that case it means that everything is larger than what the customer is ready to accept. So in that case we can just see out -1/n, and then we can continue, and otherwise we say IT minus minus and we see out the value of IT and we see out /n, and then we erase that. We do tickets dot erase IT. Does that work? 38 minus 1. Okay, this is standard. I mean other stuff is also standard, that's why I'm learning this, but I've done this kind before. Okay, restaurant customers. You are given the arrival and leaving times of n customers in a restaurant. What was the maximum number of customers in the restaurant at any time? Huh. What? Maximum number of customers in the restaurant at a given time. do we split it up? Is that what we're supposed to do? Like if we have 5 8 and 3 9, then we say that 3 to 5 is one customer, 5 to 8 is two customers, and then 8 to 9 is another customer, and then we merge with 2 4 again, and then when we're merging 2 4 with 3 5, we say basically at every point I'm maintaining a disjoint set of customers with a third, like it would be like a of pair of int comma int, like that, like a tuple. And then uh, and I change the third value to maintain the count, and I always maintain a disjoint set of segments. But then hmm, worst case I might have to update all disjoint segments. That's not nice. That will TLE. What if, okay, no, I can just sort it and I can maintain key what is the current interval in which we have multiple customers, in which we have the maximum amount of customers rather. No, but I would have to, what? But I would have to then, what if that 2% interval gets over? Okay, we can store as L's and R's, and every time we reach a L, we add a customer. Every time we reach a R, we subtract a customer. Is that it? Hmm, that seems like it. So let us now do that. Because we have the enter times and leave. Oh my god, that is. Ah, okay, okay, okay. Okay, that is. I think I've done such question also, but I'm just Uh, we take we take n, then we need three sets. We'll have a. Should I keep a multi-set? Okay, yeah. What if someone enters and someone else leaves at the same time? Hmm, I don't know if this means for the same or different customers, but okay. A multi-set of integers. We have the customers, the leaving time, the entering time. Okay. Then while n minus minus, we take int l and r. We input l and r, and then in cust we put l, in enter we put l, and in cust we put r, and in enter also we put r. Okay, now next thing to do is for int for auto j in cust. Okay, and int ct can be equal to 0 and int max can be equal to 0. If if enter dot count of j equal to 1, we can say ct plus plus. If enter dot count of j equal to 1, we can say ct minus minus. Sorry, I meant leave. And then we can set max to be the max of max comma ct. Now that I realize we can't name it max, we need to name it muxux, and then we can just output our muxux. I don't need to sort, right? Oh, okay, that's very bad. If enter dot count of j, what? Am I not input? Oh, 6? That is not right. Oh, God. Yep. In a movie festival, N movies are shown. We know the starting and ending time of each movie. What is the maximum number of movies that you can watch entirely? Okay, so if we encounter a movie that ends quicker, okay, if my current movie ends quicker than the next movie, I will of course take it. Okay, the I've sorted it by starting times, assume. The problem comes if we have our first thing sorted, but the ending time of the next movie is quicker than the starting type of this current movie. In that case, we can instead consider the ending time of the next movie to be our actual ending time, so that it becomes easier for me um to find a movie that is running. Hmm. So we'll always try to watch the first movie, right? Because if we choose the next movie, we have still watched only one movie, but we have taken more time. We have taken more time. Yeah. So we take inten cnn while n minus minus. Uh, we take a vector of pair of int comma int movies of size n. So next we take L, we take R, we input L, we input R. Why am I taking L and R? Wait. When I can just do for auto and J in movies, C and J dot first, J dot second, and that is that. So next we sort this. We sort movies dot end, movies dot begin. Next we must, okay, so for int I equals to 0, I less than an I plus plus. So this is the current movie that we're on. Okay. Um, last watched is equal to 0. 3 to 5 and then 5 to 8. That is the two movies that this is talking about, I think. Yeah. So if movies of I dot first is greater than or equal to whatever was the last movie that I watched, we will say int I equals to 0. No, why did I do int I equals to 0? We just need to do int ct equals to 0. We'll say increment ct, that's it. Else ct. Yeah, that's it. And then we say last watched is equal to the minimum of last watched, comma, movies of I dot second, right? And then we can just see out ct. We sorted it and then okay. Movies has a size of n. We input n 3 seg. We have last watched movies of I dot second int I equals to 0. Movies of I dot first, j dot first, j dot second for all j in movies n 3. Where are we? Oh my god, what how, why did I do that? No, we can't actually see 3 movies. We would have what, 3549 355849 if I'm not wrong, right? So we'll first watch 3 5. Oh wait, oh god, this needs to be in an else statement. No, wait. But then this will always just take 0, take 1 in, take 0 the last watched. And we'll say last watched is equal to movies of I dot second. Array of n integers, find two values at distinct positions whose sum is x. Oh god, two sum. Wow. That was straightforward. Okay, I just feel like because I said that I'm going to get an error. Oh wow. Um. Okay, it's probably because of the impossible and the return statement. Uh. We have a temporary variable. We input it. I feel like this should be right. Why is it not right? Um. Okay, I really want to see the test cases, but is the spelling of impossible correct? Seems right. What? That seems right. We have temporary variable temp. We input temp. Oh wait, what do we need to output? Oh, we need to output the indices. Oh. Okay, okay, okay. Uh, okay, we need a for loop then. Taken a temp. We'll say if nums of x minus temp is greater than 0, we'll output I, and nums of x minus temp, and then we say nums of temp can be set to x, can be set to I plus 1 rather. What is the problem with the cout? 4 and 2 barobar. So now the edge case for this is when we have two of the same variables. No, even for this, even for like if 8, if we have like 4 and 4 in the end here, I think it should give 4 and 3, right? Yup. Okay. Okay, I'm really happy that it was just a problem of me not reading the question. Okay. Okay, cadence. Given an array of n integers, find maximum sum of values in a contiguous non-empty subarray. Okay, we have seen this question before. We will, okay, I will try to implement without looking at my text, without looking at the textbook. Um, where is my mouse? Okay, so we need to go int n cnn vector int a n for auto and j in a cnj. Yep. Next for int I, wait, for int I equals to 0, I less than n, I plus plus. So we need a cursum and we need a answer. Okay, so at all points, if cursum plus a of I becomes less than 0, we set the cursum to be equal to 0 instead. Then we say cur plus equal to a of I, and then we say that ans equals to the max of ans comma cur. See out. Okay, so why are we saying 8? Why is the answer 9? Okay, so we start with ans equals to 0. At the 0th index, I say that cur plus I'm considering the first guy in my thingy. That's why this needs to be an else statement then. No, it needs to be a 0. Does it? Ah, was not aware. Okay, no, it does not have to be a 0. Um, so we have a current sum. What if instead of cadence we can just make a prefix sum and a set of sums up till that point, and then we just choose that, and then we just choose the index up till that point wherever the sum was minimum, and find the maximum sum for the current r, like if like current like sub array with current r, and we update max. Okay, I know that's an option, but we need to do something better here. I mean, we need to do cadence here, specifically cadence. Okay, what is my wrong? Why am I wrong? Um, so cur will always remain positive, right? Yup, cur is always positive because the moment it becomes threatened to be 0, we turn it to be 0. So if cur is always positive, then the moment it is threatened to be 0 means that a of I is also negative, right? So cur must be set to 0, man. I mean, I don't know. Cur should be set to 0, then that is the correct way to go about it. And in the other case, we increment cur by a of I. And then we take the maximum, and ans starts off as 0, so we can't so we are not by mistake taking. Oh wait, a non-empty subarray, right? What if that's the part of it that I'm missing? Ah, contiguous non-empty subarray. So if no subarray sums to a positive number, then we must simply print the maximum element, right? Ah, that is a solution, but I don't feel that is right. Like, what if we just go 2, -1, -2? I would want the answer to be -1. So if I instead go here and make it -1e9, does it then work? No, it still gives me 0 because I'm setting cur to 0. Huh. Uh, okay, we can let it be inside this. No, but we only Whew. Wow. If all of it is negative, I won't choose all of it being negative anyway. So it won't make sense. Okay. Because the only time that this gets an max of ans comma cur is going to update my cur is when we choose something. We can choose 0, right? Yeah, we can. There can be a 0 as well. So uh, we can't just put that we can't just put the case key having a lot of zeros. Yeah, we can't just say that if we have a 0 we print out minus 29. We must check that everything is uh, okay. I think we just go for flag then. No, we don't, but there is a solution without using all this. Okay, we'll try to figure that out. Wait. For so the logic is we maintain a current sum, and whenever something threatens to take the current sum into negative, we'll see that instead of bringing it back into positive by adding more elements, it's better to just start the count there. Start the uh, shit 22. Okay, so if I just keep it as minus 29 and I move it inside this, then I think this will give 0, but this will give. Wait, this should also give 0, but then this will give 1 minus 29. Yeah, so if an is less than 0, see out the value of the maximum element from a dot begin to a dot end, uh, and then else we just see out ans. So in this case we go minus 1. Yeah, does that work? Okay, it's accepted, but what is Cadence supposed to be doing? Uh, oh, wait. So instead of this, we just need to let it be. Is that right? We do not let it be an empty subarray ever. Oh, uh, but then in this case, it fails for this guy, right? Because the first element is a negative element. It includes that. Hmm. So we just need to make sure that it does not include that. This seems like cheating. I don't know. I feel this should work as well, but from the corner of my eye I saw a two line solution in the CP book. So how would a two line solution work? Wait. So I can either consider, we can end at one index before or current less than 0. Yeah, we can end at one index before or we can add the current index. Uh, so we either make it cur plus a of I. Oh, is that what we're supposed to do? So in both these cases, the thing is that it is better to consider myself alone. It is better to consider the current index alone instead of the whatever the maximum subarray that was ending at that point was. Ah, okay, wait. That is why I saw the weird minimum sign there. So cur can be set to the maximum of either cur plus a of I or a of I. Wow. So what I was doing here actually is right. This is the condition that it is checking. Okay, I was thinking about it as cases, but the actual condition is it better to start at the current or is it better to consider the previous? Okay, we can just get rid of the whole thing then and say cur is equal to the max of a of I comma cur plus a of I, and this works. Wow. We need ANS, we need cur. Can can I make the code any smaller? Nope. Submit. Choose file cp main cpp submit. I think, yeah, that's crazy. Wow, that is very nice. Wow, nice. Okay. Stick lengths. There are n sticks with some lengths. You your task is to modify the stick so that each stick has the same length. Okay, so we have n sticks with some length. The task is to modify the stick so that each stick has the same length. You can either lengthen and shorten each stick. Both operation cost x, where x is the difference between the new and the original length. What is the minimum total cost? Okay, so basically we just need to choose some length L and then find the cost to um to lengthen everything to L and shorten everything, lengthen everything shorter than L to L, and yeah, make everything bigger than L, also shorter. Okay, so how can we do this? We can have a set of all the sticks. Then if I choose any given L, what we are basically doing is we will add L minus, we will, it's basically the absolute sum of absolute differences, right? We need to minimize the sum of absolute differences. Yeah. So how does moving 1 over affect us? If I sort my sticks, right? Let's say, okay, so the first thing that I realize is we can choose to be at a stick, like we must choose to be at a stick, like we must choose to bring them all down to some given pi, because like if we choose some pi, some length L between, let's say, pi and pi plus 1, then instead of having to, then instead of going like pi plus 3 and then pi plus 1 minus 2, we can just choose pi instead and only change pi plus 1 by 5 units. That's it. Okay, so we know that we must be at some pi. So in a sorted list pi, right, I only need to check that. Okay, then how does it change as I go from pi to pi plus 1, right? Um, we can maintain the length. The length is just the like I iterate what the iterator variable, and that length whole has to be increased. Okay, basically we just assume that everything we have the current operation cost, which is to make everything to some pi. Okay, then when we move to pi plus 1, we just need to make all of those to pi plus 1, so that's just another addition. Okay, yeah. Wait, it's easier to explain with like I just if I have some sorted sticks. Okay, when I'm considering this guy, hmm? Oh wait, no, I just messed up. Wow. Okay, we can first find the cost for all the previous to measure up to this guy. Then we can find the cost for all the after to measure down to this guy. I don't know. This just sounds very tedious. And all of them, all of them will be moved back up. So means the number of operations is negative operations, and all of these guys will be moved up, so we'll have positive operations. Okay, yeah, it's basically we just check if we bring everything to this length, everything to this length, everything to this length, everything to this length, which one of them will have the minimum number of operations. So we ha okay, so let's say we've bought all of this stuff to this height. Then when we want to bring it to this height instead, what we do is we do n minus I plus 1, n minus I plus 1. This is the number of sticks that the negative operation will be performed on, and I is the number of sticks that the positive operation will be performed on. Okay, so n minus I plus 1 into pi plus 1, right? Pi into pi plus 1 minus pi, basically delta pi. Similarly, I plus 1 will also be multiplied by delta pi, and this is negated, this is added at every, and then we just have an answer variable. That's it. Okay, that's yeah. We are looking to speed run this, so it's good. The quicker we go through this stuff and reach some harder stuff in the end. We need an end. Okay, yeah. I think we can just get rid of this. So again, we go through I less than n, I plus plus. We can also sort. Um, what do we sort? A dot begin, comma A dot end. Uh, we say int init cost is equal to accumulate A dot begin, A dot end 0. This is just the cost, but we don't need to bring it up to we don't need to bring it like we don't need to bring it down, like this is the cost to bring it down to 0, bring everything down to 0. So we only need to bring it up to the first. Okay, so I think just keeping a prev is actually even more helpful, and prev is equal to int prev is equal to 0, and int ans is equal to init cost. Okay, so we'll say init cost plus equal to, we'll say I plus 1. Okay, no, this means that we have a stick at 0 that just messes with the calculations. um, or we can just say I, right? I think, why can't we just say I? um, because at the second stick when we need to go one, we need to say that one stick needs to be brought up to the current level. Yeah, so current level, yeah, and then everything accumulated. Yeah, so it needs to be I into um what, a of I minus prev, then init cost minus equal to n minus I into a of I minus prev is equal to a of I, ans is equal to minimum of ans, init cost cout ans 5. Yep, submit. Okay, wrong answer. How can this give the wrong answer? What is wrong in this? Okay, n minus I seems wrong. Wait. No, because the current one was also reduced down to that length. So we need to increment that guy as well. Yeah, n minus I is correct. A of I minus prev init cost is incremented by I. So I is the ones previous to the current stick that need to be brought up to this particular length. Then init cost minus equal to n minus I is all the ones after that could have been stopped earlier. Hmm. What is wrong in this? I think we have to. No. Okay, we won't see. We'll debug this. Uh. Okay. No, I give up. Oh, it's some kind of integer overflow. Wait. Task. Uh. Okay, it's some kind of integer overflow. Okay, so instead of doing this, we can just do I into a of I minus prev. So I minus n plus I. So it's 2 into I minus n into a of I minus prev must make the. So now that I'm not doing n into a of I minus prev, I think this should make it easier, except that it won't. No, I think it does. I think it does. Uh, yeah, because 2 into I minus n means that worst case is we are at 2e10. No, wait. So 2 into I is 2 minus n gives us like, let's say we're at like 4e5 or whatever. Then we multiply that by 1e9 at max. We reach 1e14. Yes. Yeah, that's not an overflow. Okay. Okay, but where was the overflow coming then? I into, was it from an addition? No, but it shouldn't. It shouldn't reach 1e18 at all, right? Using int. It shouldn't reach 9e18. Hmm. Where is the overflow? I don't get it. Oh, is it? No, it's not. It's not the sum. It's not the accumulate, right? Oh, wait, wait, wait. It could be the accumulate function. Uh, Vector long long. Okay, int in it. Oh my god. This was the. Oh god. That's so dumb. Shit. Okay, no, that's good. This is the kind of mistakes that someone should know of before they. Is this the problem? Was this the problem? Okay, yes. Oh god, that's so dumb. Oh god. Okay, cool. Okay, missing coin sum. You have n coins with positive integer values. It is the smallest sum you can not create using a subset of these coins. DP, right? Is it not DP? The first input line has an integer and the number of coins. The second line has an integer x1, x2, xn. The value of each coin. Yep. Okay. Huh. Okay, so it is subset. We can only use the, even we can only use each coin once, right? No, but if all the numbers up till 2e5 are just the powers of 2, I mean not all the numbers, like 64, the 64 numbers are just the power of 2, then we can already make everything up to 9e18. Then how do we, then we'll have to use big integer. No, that does not seem right. Okay, so using 1e9, whatever we get, we can definitely not make the number 3e9. Okay, except if we have 1e9 thrice. Actually, yes, that's my fault. We can definitely not make the number what 1e15 maybe. Yeah, we cannot make the number 1e15. Cannot create using a subset of these coins. Can I binary search on answer? I'm just throwing everything at this, like whatever I know. Okay, if I have some number k, how do I know if it can be created using this? We can know that if no, we can't do a no, we can't do that. Smallest coin sum. How do we know the smallest coin sum? If we just find the order in which yeah, so between 1 and 2e5 there definitely should be a number that we cannot create, right? Because the only way that 1 to 2e5 everything can be created is if it's just one. Okay, if it's 1 2 3 4 5 6 7 8 9 up till 2e5, then we can create up to 2e5, and we can create up to 2e5 plus 1 as well, meaning we can create anything, like we can use 2e5 and after that huh and after that we can create all the numbers up till 4e5 as well. No, we can't create the number 4e5, right? Please tell me we can't create the number 4e5. um to create 4e5, no, we can just use 2e5 and 1 and 2e5 minus 1. Shit. uh what can I not create, man? Smallest sum cannot create using a subset. Smallest sum that we cannot create. What is the smallest sum we cannot create? Bro, what? Wait. Um. Okay. So let us say we have the total sum is equal to SUM, and okay. So must come from where? So every subset can be considered to be a part of some minus, no, every subset can be considered to be just pi plus pi plus 1 plus dot dot subset, right? Not subarray. Okay, subset. Hmm. Hmm. What? How can this be done in O of n? That does not make sense to me. 2e5 xi goes to 1e9. 29127. What? Um. Okay, we can represent some of the subset to be some pi plus 1 plus dot dot dot, right? So the smallest sum that is not equal to this would be what? We can just choose every, but that would be n square. But this must be, how do I think I give up. I hope to find the answer here, because if I don't, then I have set a no finding rule upon myself. So we do not have any idea. Meet in the middle. I doubt it's something. I doubt it's something complex. I'm guessing it's something really easy that I just cannot think of. What are the operations of what? Okay, the requirement is that we simply go over every element, perform some operation, some O of 1 or O of log n operation on either a set or a array, and somehow magically get the hmm maybe we find for each sub array the smallest. No, that does not make sense either. Hmm. What? Okay, I think we just skip this. I'm given an array that contains each number between 1 and n exactly once. Task is to collect the numbers from 1 to n, increase order. Each round you go through the array from left to right. Collect as many number of possible. What will be the total number of rounds? Collect the numbers from 1 to n in increasing order. So how do we collect numbers in increasing order? We go, we just store stuff in a stack, right? Yup. Um, but we can't go through n stacks. So instead, to collect the numbers from 1 to n in increasing order. Okay. Okay, so it's just how many inversions are there, right? Because every time we see an inversion, we have to start from the start. Yep, so it's just how many inversions are there. Now the question is, how do I count number of inversions? Well, I mean, if it's 1 to n, then we just need to know the size of the, we just needs to know the size of the set greater than n. So we'll need an ordered set. Okay, if what if I don't want to use an ordered set? We can't use an array for the binary search because we need the insertion operator. Instead, we can, no, we don't need to go for every inversion. We only need to go when n plus 1 is when I and I plus 1 are in an inversion, right? Because if I plus 1 and I plus 2 are straight, even if I plus 2 is before I, we don't take another turn. Okay, so if it's just I and I plus 1, then it's easy. Yeah, okay, that's nice. Okay. Okay, so we think about the coding before we code it, right? So, um, every time we see a, every time, okay, so, okay, so, huh, 1 and 2 are in an inversion, 3 and 4 are in an inversion, so that's why it takes us 2 rounds, right? Oh, okay, yeah, so plus 1 round because 1 is by default, you'll take 1 round at least. So, we're taking our first round, then we run into the fact that we need to go around again to get 2. Then do we need to go around again to get 3? Right, that is it. So we just input them. We store a set of integers a for int I equals to 0, I less than n, I plus plus. Mm, ct equals to 1 if a dot count of a of I. Okay, we can't make this int a, we need to make it nums. If in nums we can find a of I plus 1, it means this current a of I is going to be the end of a round. So if it's the end of a round, we need to update the value of ct, and then we'll just insert the value of a of I, right? And then we can just see out ct. Yup. Okay, that is nice. What is that coin one, man? It's not striking me. Feel it should be something very simple that I'm going to feel very dumb when I see why I wasn't able to do it. But subsets, How do I know an O of n? What I cannot. Okay, we'll look at that later. I'm given an array. We need to collect 1 to n. Collect collected an increasing number on each round. You go through the array and collect as many numbers. Given m operations that swap two numbers, task number of rounds after each operation. Okay, so whenever an operation happens, okay, so we need to think of when the operation happens. Okay, so let's say this operation happens. Let's say this was the end of a round. Okay, so this is the end of a round, means that a plus 1 was here. So if this is the end of a round, it remains an end of a round. Okay, now if this, however, okay, and now if a plus 1 is here, however, then not, it is not end, it becomes end. So similarly, if b plus 1 is here, this is not end and it remains not end. And if it was a end and b plus 1 was here, then we get not end. It is an end and it becomes a not end. Okay, so we just need to calculate that. So the changing condition is only that if this is a not end, no sorry, if this guy is an end and we have our b plus 1 here, the number of rounds will be decreased. Similarly, if this was an end, have our a plus 1 here. Oh wait, okay, so based on a minus 1 also the answer can change. If we had our a minus 1 here, then as it moves here, we get a new round, right? We get an extra round. Okay, similarly, if we have a b minus 1 here, we get an extra round. Okay, yep. Okay, so let me just remove that whole thing. Okay, we have a, we have b. Okay, so for a, if we find an a plus 1 between a and b, then when we move there, we now have created a new cycle, because find a, go to the end, come back to start, so that we can find a plus 1. So in this case we'll increment the cycles. Okay, then if we find a minus 1 between a and b, then we'll decrement the cycles. Similarly, if we find a b plus 1 here in between, then it means initially there is a cycle, but now there won't be. And similarly, if we find a b minus 1, we'll say plus plus. Now the last edge case is if a is equal to b plus 1 or b minus 1, right? Numbers to be swapped. Since a and b are swapped. Okay. How do we now make sure that? Okay, so what happens if b is equal to a plus 1? To a plus 1, then we add a cycle, so we don't need to do plus plus. We don't need to add 2 rounds, that's it. So as long as it is not one of those boys, I think it works alright. Yeah, okay. So if B is just A plus 1 or A minus 1, we just break out of it. Oh, that's not true, right? Oh, wait. Uh, if B is just A plus 1, then we don't need to do this B minus 1 thingy. But we do need to do this B plus 1 thingy still. Huh. Okay, that is annoying. Okay, but A minus 1 will take care of it. So in A, we'll do it inclusive of A and B. And in B, we'll do it exclusive of A. Okay. So we take nums. Think we make an array of indices. Again, n size, n plus 1 size for int I equals to 0, I less than n, I plus plus idx of a of I. So the index of a of I said to be I plus 1. So now we have the index as well. So now I just need to do this. So, oh wait, um, we need this actually. Yeah. Okay, that's cool. So now we only need to do while m minus minus, we'll have an int l and an r. We'll input an l and an r. Okay, if okay, so we must go l minus minus, we must go r minus minus. Okay, so first we'll do the operations for the left one. Okay, so if a of l, if the index of a of l, okay, so wait, okay, so let us plus first see a plus 1, wait, so a plus 1, a minus 1, b plus 1, b minus 1. Okay, so a plus 1 is equal to a of l plus 1, a minus 1 is equal to a of l minus 1, b plus 1 equals to a of r plus 1, b minus 1 is equal to a of r minus 1. So next what we do is we call a, we check. So the first thing is if the index of a plus 1 is greater than l, or the index or not or and the index of maybe we should just go and say n plus 2 comma minus 1, because yeah, uh, and index of r less than equal to r, and index of a plus 1 less than equal to r. So in that case we need to say Where is this? So for a plus 1 we increment ct plus plus. If index of a minus 1 is greater than equal to L, and index of a minus 1 is less than equal to R, we say ct minus minus. Then if index of b plus 1 is greater than L, and index of b plus 1 is less than or equal to R, we can say ct minus minus. And if index of b minus 1 greater than L, and index of b minus 1 less than equal to R, we can again say ct plus plus. Then we say cout ct slash n while m minus minus. 232 was not right, right? 234 होना चाहिए. हाँ. Oh, we aren't swapping. अरे. Okay. So how do we swap is we say index of a of L is set to R, index of a of R is set to L, and we swap a of L with a of R. What? Uh, why? Huh? What am I doing wrong? अरे 234 पे करेक्ट तो आया. गलत क्या हो रहा है? Which code got submitted? The code that got submitted is correct only. Why, how is this wrong? Oh, this. Okay, it's L equal to R case. Okay. L equal to R. Just cout ct. हाँ माँ. हाँ बरं. Is that the problem? Wow, that's a very nice problem to have. I really hope that is the problem. Because I don't think my logic is wrong. Hmm. 9, 10, 10 क्यों आ रहा है? So for the first one, we output a 9. That is right. For the second one, we are saying it's a 10. Sorry, we are saying that it remains a 9. So 10. Oh, okay. Far greater than L. What the fuck? Huh? What? Wait, this, how could this possibly ruin anything? Huh? Oh, sorry. Okay. Wow, my implementation is very shit. Ah, god damn it. Wowies. Playlist. Given a playlist of a radio station since its establishment, the player end songs. Longest sequence of successive songs. What does that mean? Oh, because we can go 1, 2, 3, 7, 4. Is that why? Then can't we just play all the unique songs? Is it not just the unique? Is it not number of unique elements? Why won't it be just number of unique elements? Because we can just choose the first unique element, then skip over, then find the second unique element, keep doing that, and we are done. We just have a num, we just int. I do not understand the question. No, I doubt that's it, but maybe if I see the test cases, I'll understand what the question is. I don't get what the question is. So I said So I said we can play 3 songs because we can play 3, then 5, then 1. No, I said we can play 4 songs, so you can play 3, 5, 1, 4. But it's saying 3 songs, which is okay. 3, 5, 1. Okay, it's looking for okay. Okay, successive. Array, chi, array, bhai. Okay, that's just sorry. So we can keep 2 pointers. We expand one until we see something that is already been seen. Then the moment something's count becomes 2, we then bring back our L until the count becomes 1, uh, and then we increment the answer. And then since the R and L only move n indices each, so it is O of an algorithm. Uh, Next, we go incrementing the value of L. We say yes, we include R. Then we say yeah, we increment the value of L until we have finally excluded somebody who was actually hindering our growth. And at every point after that, we simply say ans is equal to the maximum of ans comma L minus R plus 1, right? That should work. 1. Wow, that's insane. Okay, so ans is equal to 1 and L is equal to 0, and in the CT we have okay. Wow, I would be very annoyed if I did this in contest, and I have done this in contest. That is pitiful. Uh, why did it still not work? So we have 1 1 and L is at 0. Okay, so we start with R is equal to 1. So we have made this to be 2. Okay, so now while CT of A of R greater than 1, so it will not go into this, it will instead increment L and R here. Why is it going into CT of A of R greater than 1? Hmm. 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 Why would it possibly do that? Hmm. Oh my god. Silly mistakes galore. 5. Submit. Choose a file. CP workspace and submit. Uh, what? Not again. Where is it wrong? Why can't it just be right? Who said 2? Who said 2? What? ANS is equal to 1. We make the answer to be what? Why would this possibly output 1? Why would this possibly output 2? This should output 1 according to me. 2. At what point? See out I R L CT1. Oh, slash n. Oh, sorry. We don't have an I. That's very nice. 1 and 1 and 1 and 2 and 2 and 2 and 3 and 3 and 1. 4 and 4 and 1, 5 and 5 and 1. In the end, it becomes 9 and 8 and 1. Where is the end? Why does it become 9 and 8 and 1? Uh, wait. Why does it become 9 and 8 and 1? 102. It starts off at as 9 and 8 and 1. R naturally goes to 9. L starts off at 8. CT of 1 is not being updated. So CT of A of R needs to be updated and it's not. How? What the hell? A of R. Huh. Excuse me. What? 1 2 3 4 5 6 7 8 9. 9 elements. Why can't it just n? What is m? Okay, what is m? Wow. Okay. Wow, that was insane. This is why I don't. This is why I'm not expert, I think. Yeah, that should pass, I think. Oh, that gave wrong answer on everything. Wait, what? Am I outputting something? No, right? Huh? The another. Okay, the file didn't get saved. Um, wow, this is very dumb shit. Can we just move on to the next one, please? Okay, finally. Okay, towers. I'm given n cubes in a certain order, and your task is to build towers using them. Whenever two cubes are on top of the other, the upper cube must be smaller than the lower cube. You must process the cubes in the given order. You can always either place the cube on top of an existing tower or begin a new tower. What is the minimum possible number of towers? So we can create a minimum possible number of towers by we first place 3 down, we place 8 down, we place 2 on the 3, we place the 1 on the 3, we place the 5 on the 8. I think that is correct. So whatever is the smallest one, we just insert into that, right? That's it. Do we need to prove it? Do we need to prove it? Uh, do we need to prove it? Um, must be smaller, not smaller than equal to. So we need to go for a lower. We'll say towers dot insert num. Yeah, we don't need this. We just need the towers dot size. Okay, and then else auto it equals to towers dot lower bound on num. Then we say it minus minus. Then we say towers dot um, erase it, towers dot insert num, cout towers dot size. Okay, that's not right. Why am I coming to a 3? So we first come in, we place the 3 down as a tower. Next time that we come in, Okay, so we need to find something bigger. Oh my god, what am I doing? Okay, so because we need to find something bigger, we see upper bound, and then tower should not be equal to towers dot end. In the other case, we say auto it equals to it minus minus. Upper bound is the smallest number that is bigger than the current number. So that is why we can just remove it and insert num. Yeah, I think that should also be over, right? Oh wow, so many wrong answers. Wait, is my logic wrong? As something comes in, I'm greedily placing it. That's it. Hmm. So greedily placing is not the solution apparently. Why can't we just greedily place it as something comes in? Yeah, why was the, so if something comes in, if it can either be placed or it can be made into a new tower, if it can be made into a new tower, then all the new stuff will anyway fit over it. So I can just put it there instead, right? Like if it's like 835, it doesn't matter if I do 8 5 on one tower and 3 another alag se, or I can do 8 3 on one tower and then 5 alag se. Hmm. It's least number of decreasing sequences, monotonically decreasing sequences in n. Can I just see my wrong answer? Oh, oh my god, wait, what? Okay, no. Oh, okay, multi-set. Wowies. So it will pass a few more tests. I'm guessing because it's multi. Oh, okay. But passed everything. There's a street of length x. Oh, shit, man. We considered the equal to case, but we did not consider the multi set. Wow, that's just okay. Whatever. Hmm. There is a street of length x whose positions are numbered 0, 1, x. Initially, no traffic lights, but n sets are added to the street one after another. Position of each set of traffic lights, each position is distinct. So whenever I insert a traffic light, I am dividing that particular segment into two segments. So initially I'll have one full segment 1 comma x. Hmm. So during each addition, one of them gets reduced. So when I add it to 3, okay, so it is a, yeah, so it has to do with segments only, definitely. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, right? That's 9 elements. Now from those 9 elements, right, when we place on 3, we either have 0, 1, 2 as one of the, so it is pi minus 1 and pi plus 1, right? I agree. Uh, and we might have to ignore pi minus 1 in that case. Or we can just consider there to be an traffic light at the end of every intersection. Uh, use of this is, then we can just say r minus l is the difference as well. And whenever we insert a traffic light, the insertion becomes much easier and much lesser checks, and we always maintain a continuous list of traffic lights. We don't, like, if two traffic lights are inserted, then we have a, yeah, I agree, we will have a empty only traffic light segment as well as a full, like, multiple traffic light segment. So in this way it becomes easier. Okay, so we'll need our x comma n, again x n, we'll say set of pair of, oh, okay, I get the thingy majingy now. I'll need two sets of pairs of int comma int. I'll have one set of pair of int comma int just to give me the segment, just to give me the segments. Then I'll need a set of pair of int, no, I'll need a set of pair of int comma pair of int comma int. uh, but that won't work, will it? No, yeah, it will work because I have the int comma int with me. Yep. Wow. Int comma int, and this is the uh, distances. Now while n minus, okay, wait, so the first thing to do is that in segs we put so we'll have to put z 0 comma x plus 1, and in distances we'll have to put uh, x plus 1 comma 0 comma x plus 1, right? Ouch, that hurt. So we'll take a position, we'll input that position, we'll binary search over segs for the position, for the, what do we need to binary search on? Starting from that position, so lower bound p comma 0. So this will give us Okay, no, I think upper bound is better. So can p comma 0 upper bound end up giving us segments, the beginning of the segments? No, right, because the beginning will always be 0 comma something. Yep, I agree. So even if we put 0 itself, the upper bound, so only if we put -1 we can reach segments or beginning. So we don't need to worry about that. So we can say auto IT hai, and then we can also say some auto other, I don't know, is equal to the prev of IT. So now we have IT as well as we have other, okay? So now, so IT does not have any relation with prev with P at all. So all that we care about is ITZ. So we don't really care about IT. So you can just update the whole thing to prev. Okay, so now prev contains PI. Okay. So what we do is we say pair of int comma int equals to uh, the value at IT. Next we say distances dot erase okay, wait, pair of int comma int cur dot first cur dot second minus cur dot first comma cur okay, then we'll say uh, pair of int comma int cur1 equals to the value at IT, sorry, not the value at IT, it will be cur dot first to P. Similarly cur2 int comma int cur2 will be P plus 1 comma cur dot second. And now we do segs dot erase IT segs dot insert cur1 segs dot insert cur2 distances dot insert cur1 dot second minus cur1 dot first comma cur1 distances dot insert cur1 cur2 dot second minus cur2 dot first comma cur2. See out the value of distances dot rand slash n, right? So does that work? 334 533 what? Wait. R begin 532. How could it give 532? Yeah, so the last thing cannot be a 3, right? This is right. I am right. There are no traffic lights, but n sets of traffic lights. Length of the longest passage without traffic lights. We can have either 0, 1, 2, or we can have 4, 5, 6, 7, 8. Right, so that's why we get 5. Next, we can have either 0, 1, 2, or we can have 4, 5, or we can have 7, 8. Okay, then we can have 0, 1. At 2 there's a traffic light, at 3 there's a traffic light. We can have 4, 5. We can go through 4, 5. Then at 6 also there's a traffic light, so we can instead go through 7, 8. So the largest is 2. Brother, what the hell? Length of the longest passage without traffic lights. I don't get it. What? What the fuck? I don't get it. You can go from 0, 1, or you can go from 4, 5, or you can go from 7, 8. That is it. There are no other trafficless segments at all. नहीं पता यार, नहीं समझ रहा. What? How can I? It is not possible only. The only segment that you could travel. Ah, shit, wait. हाँ तो X. अरे 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, initially we had 9. Okay, we added it to 3. Huh? So now we have 0, 1, 2, or 4, 5, 6, 7, 8. Okay, so 4, 5, 6, 7, 8 is the 5. We added to 6. So we can either go 0, 1, 2, we can go 4, 5, or we can go 7, 8. Okay. Next we added to 0, 1, 2. So the maximum length is 2. I feel the maximum length should be 2. Wow. Okay, another skip. Wow, I don't like skipping, but okay. Consider a game where there are n children, numbered 1 to n in a circle. During the game, every other child is removed from the circle until there are no children left. So let's see how much we did today. Wow, that's not a good amount for having sat 4 hours on this. 13. 13 questions in. How much time has this been going on for? मैं देख नहीं सकता. Well, okay, anyway. Goodbye, future Nishant.